Now that we have reduce, we can make a few changes. For one thing, we can improve our plus function that we had before. It looked like this. All it did was add two numbers. But now that we have reduce, we can actually adjust this function so that it can take any number of arguments, because we may want to add more than two numbers at once. So how would we do this? Well, we could say plus is equal to a function that takes any number of arguments, all of which are numbers, and it returns reduce of ac and cur, ac plus cur, given the current arguments, and that's it. Let's run this. Make sure it still works. 3, 4, 5 is 12. So there you go. So plus is enhanced now. And I also mentioned in the previous video that we can actually implement map and filter in terms of reduce. And what I mean by that is we can use reduce within our implementation of map and filter. And we'll see that it makes those shorter and I think simpler to understand. So let's implement map in terms of reduce. I call it MapReduce, but really just what I mean is this is map implemented in terms of reduce. This is a function that takes another function and some collection as before. And now what we're going to do is we're going to call reduce with some function again that takes an accumulation and the current element as it iterates. And it's also going to take this collection that MapReduce is given. And we're going to start it with an empty array because our result is going to be an array. And now what we have to do is very simple. We simply take what we already have and append the application of the function to the current element. So that's map implemented in terms of reduce. And let's try it out. MapReduce, oops. Inc over 1, 2, 3. And there you go. Now what does filter look like implemented in terms of reduce? Well, it also takes a function and a collection. And again, we're going to return the result of a call to reduce. And reduce, as always, takes some accumulation and the current element. And it also takes the collection and an empty array, because again, we want to start out with an empty array and return an array. And then what we have to do, this looks slightly different now than this call in MapReduce, is we want to check, does the application of the function that we're given on the current element evaluate to true? If it does, only then do we want to keep the element, right? That's the whole point of the filter function. So if it does, we return what we've already accumulated and the current element. And if our predicate function doesn't evaluate to true for this item, well, then we want to disregard it. So we simply return what we've accumulated so far. Let's see that this works. Filter reduce even over this collection. And there you have it. What's remarkable about reduce really is that it makes these functions even simpler than they were before. So our previous map implementation looked like this. This is some 10 lines. And now it's only about 5. And the same for filter. This is about 10 lines, only 8, I think. And our previous filter function was a little bit longer than that. So now that we have map, filter, and reduce, those three are really the three main functions you're ever going to need for almost all purposes. And since map and filter can both be implemented in terms of reduce, reduce is really the one function that you can use a lot. So there you have it, an enhancement of plus and map and filter both implemented in terms of reduce.